Welcome to Quantum Magazine's podcast. Each episode, we bring you stories about developments in science and mathematics. I'm Susan Vallet. If you drive north of Perth, Australia, for about 17 hours up the so-called Great Northern Highway, you can get lonely. It's a remote area with an occasional mining community. But eventually, you'll hit the northwest corner of Australia. The hills here are softened by time and striped by layers of sediment, an open history book right there in the dirt. This is part of a region called Pilbara Craton. It formed about 3.5 billion years ago when the Earth was young. And it's in these hills where scientists have called into question a widely held theory of the solar system's beginnings. In this northwest part of Australia, there's a seam within these jumbled creamsicle-colored rocks called the apex chert. Let's take a closer look at some rock samples here with a microscope. See the tiny tubes? Some of them look like little tornado petroglyphs. Others look like flattened worms. They're not just cool looking. They might represent some of the oldest forms of life ever found. Late last year, researchers announced that these are indeed fossil life. Geochemist John Valley of the University of Wisconsin says they date back nearly 3.465 billion years. If Valley and his team are right, the fossils imply that life diversified remarkably early in the planet's tumultuous youth. The fossils add to a wave of discoveries that point to a new story of ancient Earth. In the past year or so, separate teams of researchers have dug up, pulverized, and laser blasted pieces of rock that may contain life dating to 3.7, 3.95, and maybe even 4.28 billion years ago. All of these microfossils, or the chemical evidence associated with them, are hotly debated. But if they are what they seem to be, they all cast doubt on the traditional tale. Here's how that story goes. Between 4 to 4.5 billion years ago, Earth was forming out of dust and rocks left over from the sun's birth. In the 500 million years after Earth formed, it was hellish and hot. That infant world would have been filled with volcanoes and bombarded by other planetary crumbs. Oceans of magma covered Earth's surface. Back then, Earth was not so much a rocky planet as an incandescent ball of lava. The environment would have been so horrible and so inhospitable to life that the geologic era is named the Hadean for the Greek underworld. Awful as those conditions were, things may then have gotten even worse. Not long after Earth came together, a wayward planet whacked into it with incredible force, possibly vaporizing Earth anew and forming the moon. The meteorite strikes continued. Some created craters 1,000 kilometers, or more than 600 miles across. In the standard paradigm of the Hadean Eon, these strikes culminated in an assault dubbed the Late Heavy Bombardment. It's also known as the Lunar Cataclysm. Basically, asteroids immigrated to the inner solar system and pounded the rocky planets. Throughout this early era, Earth was molten and couldn't support a crust of solid rock, let alone life. Not until a particularly violent asteroid barrage ended some 3.8 billion years ago could life have evolved. But this story is increasingly under fire. Many geologists now think that after the heat of its initial formation dissipated, Earth may have stayed tepid and watery. The oldest rocks in the record suggest parts of the planet's crust had cooled and solidified by 4.4 billion years ago. Oxygen in those ancient rocks suggests the planet had water as far back as 4.3 billion years ago. And instead of an epic final bombardment, meteorite strikes might have slowly tapered off as the solar system settled into its current configuration. The result, according to UCLA geochemist Elizabeth Bell, was that things actually looked a lot more like the modern world early on. There was water and possibly some stable crust. She says it's not completely out of the question that there would have been a habitable world and life of some kind. Taken all together, the latest evidence from the ancient Earth and from the moon is painting a picture of a very different Hadean Earth. A solid, temperate, meteorite-clear, and watery world. You could call it an Eden from the very beginning. In 2001, geochemist John Valley found tiny crystals called zircons. No, these aren't the same as the fake diamonds we call cubic zirconia. These sand grain-sized gems suggest that the planet had a crust as far back as 4.4 billion years ago. His discovery dramatically changed Earth's origin story. They tell of a cooler, wetter, and maybe livable world as far back as 4.3 billion years ago. Zircons are crystalline minerals containing silicon, oxygen, zirconium, and sometimes other elements. They form inside magma. And like some better-known carbon crystals, hint, hint, diamonds, zircons are forever. They can outlast the rocks they form in and withstand eons of unspeakable pressure, erosion, and deformation. As a result, they're the only rocks left over from the Hadean, making them invaluable time capsules. Valley chipped some out of Western Australia's Jack Hills and found oxygen isotopes that suggest the crystal formed from material that was altered by liquid water. That could mean part of the Earth's crust cooled, solidified, and harbored water at least 400 million years earlier than the earliest known sedimentary rocks. And Valley says if there was liquid water, there were likely entire oceans. Other zircons showed the same thing. Valley says he and his team learned from the zircons that the Hadean was not hell-like. Sure, he says, there were volcanoes, but they were probably surrounded by oceans, and there would have been at least some dry land. Zircon suggests there may have even been life. In recent years, fossils in ancient rock bolstered the zircon story of calmer, cooler times. Those microfossils of the Pilbara Craton are the latest example. Today, many scientists doubt or outright reject the oldest evidence for possible life. It's at least 3.77 billion years old, and maybe a stunningly ancient 4.28 billion years old. In March of last year, University College London geochemist Dominic Papineau and his student Matthew Dodd described tube-like fossils in an outcrop in Quebec. The fossils date to the basement of Earth's history. They're from a formation called the Nuvvuagittuq Greenstone Belt. It's part of Earth's primitive ocean floor. The fossils are about half the width of a human hair and just half millimeter long. They're made from an iron oxide called hematite. Dodd says they may be fossilized cities built by microbial communities up to 4.28 billion years ago. Dodd says they would have formed gelatinous, rusty-colored mats on the rocks around the vents, similar to the microbial mats on hydrothermal vents found deep in today's oceans. Dodd found the tubes near graphite, and with carbonate rosettes, tiny carbon rings that contain organic materials. The rosettes can form through different non-biological processes, but Dodd also found a mineral called apatite, which he says suggests biological activity. The researchers also analyzed the variants, or isotopes, of carbon within the graphite. Generally, living things like to use the more lightweight isotopes, so an abundance of carbon-12 over carbon-13 can be used to infer past biological activity. The graphite near the rosettes also hinted at the presence of life. Taken together, Dodd says the tubes and their surrounding chemistry suggest they're remnants of a microbial community that lived near a deep ocean hydrothermal vent. Geologists debate the exact age of the rock belt where the alleged fossils were found, but they agree it includes one of the oldest, if not the oldest, iron formations on Earth. This suggests the fossils are that old too, much older than anything found previously, and much older than many scientists had thought possible. Then, last September, researchers in Japan published an examination of graphite flakes from a sedimentary rock called the Saglik Block. It's in northern Labrador on Canada's east coast. The rock is 3.95 billion years old. Yuji Sano and Tsuyoshi Komiya of the University of Tokyo argued their graphite's carbon isotope ratio indicates that it, too, was made by life. But the graphite flakes were not accompanied by any feature that looked like a fossil. What's more, the history of the surrounding rock is murky, suggesting the carbon may be younger than it appears. Farther to the east, in southwestern Greenland, another team also found evidence of ancient life. In August of 2016, Alan Nutman of the University of Wollongong in Australia and his colleagues reported finding stromatolites, fossil remains of microbes from 3.7 billion years ago. Many geologists have been skeptical of each claim. For example, Nutman's fossils came from the Iswa Belt, a part of Greenland that's home to the oldest known sedimentary rocks on Earth. But the Iswa Belt is tough to interpret. Just as non-biological processes can form Dodds carbon rosettes, basic chemistry can form plenty of layered structures without any help from life. That suggests they may not be stromatolites, but rather lifeless pretenders. In addition, both the Nuvu-Wagittuk greenstone belt and the Iswa belt have been heated and squished over billions of years. The process melts and recrystallizes the rocks, morphing them from their original sedimentary state. Researcher John Valley says he doesn't think the studies are wrong, but he also doesn't think any of them are proof. He agrees Nutman's rocks look like stromatolites, which Valley calls very enticing. But Valley is much less cautious about his work with the Pilbara craton fossils in Australia. Those microfossils lay there for nearly 3.465 billion years before being removed and shipped to California. Paleobiologist William Schaff of UCLA published his discovery of the strange squiggles in 1993 and identified 11 distinct microbial taxa in the samples. Critics said the forms could have been made in non-biological processes. Geologists have argued back and forth in the years since. Last year, Schaff sent a sample to Valley, who has a super-sensitive instrument for measuring isotope ratios called a secondary ion mass spectrometer. Valley's team found that some of the apparent fossils had the same carbon isotope ratio as modern photosynthetic bacteria. 3 other types of fossils had the same ratios as methane-eating or methane-producing microbes. And the isotope ratios correlate to specific species that Schaff already identified. Valley says the locations where they measured the isotope ratios corresponded to the shapes of the microfossils themselves. He says they're the oldest samples that look like fossils, both physically and chemically. While they're not the oldest samples in the record, Schaff's and Valley's miniatures do have an important distinction. They're diverse. The presence of so many different carbon isotope ratios suggests the rock represents a complex community of primitive organisms. The life forms must have had time to evolve into endless iterations. This means they must have originated even earlier than 3.465 billion years ago. Fossils aren't the first sign that early Earth might have been an Eden rather than a lava-filled hell. In research published in 2015, UCLA's Elizabeth Bell and her co-authors presented evidence for graphite embedded within a tiny 4.1 billion-year-old zircon crystal from the same Jack Hills. The graphite's blend of carbon isotopes hints at biological origins, but the finding is once again hotly debated. Bell concedes there are explanations other than life, sure, but she considers this the most secure evidence for some sort of fossil or biogenic structure. If the signals in the ancient rocks are true, they're telling us that life was everywhere, always. In nearly every place scientists look, they're finding evidence of life and its chemistry, whether it's in the form of fossils themselves or the remnants of life long ago. Bill Bottke is a planetary scientist at the Southwest Research Institute in Boulder, Colorado. He says life was managing to take hold at the same time Earth was dealing with the worst impacts it's ever had. Or maybe not. Maybe those impacts weren't quite as rapid fire as everyone thought. We know asteroids bombarded Earth and everything else in the past. The Moon, Mars, Venus, and Mercury all carry the scars. But the question is when, and for how long? Based largely on Apollo samples brought home by moonwalking astronauts, scientists came to believe that in the Earth's Hadean age, there were at least 2 distinct epochs of asteroid pummeling. The first came right after the planets were formed. The second came later, known as the Late Heavy Bombardment, or the Lunar Cataclysm. Isotopes of potassium and argon in Apollo samples suggested bits of the moon suddenly melted some 500 million years after it formed. This was taken as evidence that it was blasted within an inch of its life. That bombardment tapered off about 3.8 billion years ago. Zircon crystals also provide tentative physical evidence of a late-era hellscape. Some zircons contain shocked minerals, evidence of extreme heat and pressure. Many are younger than 3 billion years, but UCLA's Elizabeth Bell found one zircon suggesting rapid extreme heating around 3.9 billion years ago, a possible signature of the late heavy bombardment. Bell says all we know is there's a group of recrystallized zircons at that time period, coinciding with the late heavy bombardment. She says it could be connected, but to really establish that, they need to look at zircon records from other locations around the planet. So far, there don't appear to be other signs. In 2016, Patrick Behnke, who is now at the University of Chicago, took another look at the original Apollo samples. Remember, for decades, they've been the main evidence in favor of the late heavy bombardment. He and UCLA's Mark Harrison reanalyzed the argon isotopes. They concluded that the Apollo rocks may have been bombarded many times since they crystallized from the natal moon, which could make the rocks seem younger than they really are. Behnke says even if you solve the analytical problems, there's still a chance that astronauts from the 6 Apollo missions sampled rocks from a single asteroid strike on the moon. Scientists are also using data from moon-orbiting probes, like the Gravity Recovery and Interior Laboratory, or GRAIL spacecraft, and the Lunar Reconnaissance Orbiter. They found nearly 100 previously unknown craters, including a spike in impacts as early as 4.3 billion years ago. Planetary scientist Nicole Zellner of Albion College in Michigan says this interesting confluence of orbital data and sample data, and all different kinds of sample data, point to something that's not a cataclysmic spike at 3.9 billion years ago. Bill Bottke, who studies asteroids and solar system dynamics, is one of several researchers coming up with modified explanations. He now favors a slow uptick in bombardment, followed by a gradual decline. Others think there was no late bombardment, and instead, the craters on the moon and other rocky bodies are remnants from the natural process of planet building. Bottke says they're working with a tiny sliver of data. He says you try to build a story, but sometimes you just chase ghosts. While it plays out, scientists are debating much bigger questions than early solar system dynamics. If some of the new evidence truly represents impressions of primeval life, then our ancestors may be much older than we thought. Life might have arisen the moment the planet was amenable to it, the moment it cooled enough to hold liquid water. When John Valley was young, he was taught that it would take billions and billions of years for life to form. But he says he hasn't been able to find any basis for that. He points out it's quite possible that life emerged within a few million years of when conditions became habitable. But he says from the point of view of a microbe, a million years is a really long time, but it's a blink of an eye in geologic time. Valley says there's no reason life couldn't have emerged 4.3 billion years ago. And that brings us to another interesting idea. If life on Earth could have survived such inhospitable conditions, life on other planets might be more plausible. Michelle Yoon helped with this episode. I'm Susan Vallet. For more on this story, read Rebecca Boyle's full article, Fossil Discoveries Challenge Ideas About Earth's Start, on our website, quantamagazine.org. Also, head on over to quantamagazine.org and take a 5-minute audience survey by July 16th, 2018. You could win a free Quanta t-shirt.